Hi everyone, this is part 2 of the lesson on solving systems of equations with three variables by elimination. So what I am going to do, and I'm going to pause the video here, but I'm going to tell you what I'm going to do next. I'm going to take the first equation and also the third equation, okay, and I'm going to copy them here. So all I've done is I copied equation number 1 and number 3, and you'll see why in a moment. Okay, since this is called elimination, as you can see, the x's are going to cancel, so the x's get eliminated, and now for the rest we add whatever's left. So y minus 2y is negative y, and 2z plus 1z, that's equal to 3z, and then 3 plus 10, that's equal to 13. Okay, so then we have this equation, and what I'm going to do next is I'm going to combine two other equations, and that is I'm going to take the second equation and the third equation. So watch what I'm going to do here. So I'm going to copy. So I have 2x plus y plus 3z equals 7. So that's the second equation. Then I'm going to copy the third equation just the way it is here. So I can eliminate the x's again. So negative x minus 2y plus z equals 10. But since I want to eliminate the x's, this is negative 1x, so that means I need to multiply this equation by a 2. Okay, so then when we multiply, I'm going to copy the first equation as it is. So that's 2x plus y plus 3z equals 7, and then I'm going to distribute 2 times negative x, that's negative 2x, 2 times negative 2y, that's negative 4y, and then 2 times z, that's plus 2z, and that equals 2 times 10, which is 20. Okay, so then as you can see, the x's are going to cancel. So I have y minus 4y, that's negative 3y, and then 3z plus 2z, that's plus 5z, and 7 plus 20, that's 27. Okay, so what I'm going to do next, I'm going to take this equation and this equation, and I'm going to copy them down. Okay, so I have negative y plus 3z equals 13. And this one here, that's negative 3y plus 5z equals 27, right? Okay, now I'm going to eliminate the y's. Notice that this is negative 3y, this is negative y. So I'm going to multiply the first equation by a negative 3 to make those y's positive. So then distributing negative 3 times negative y, that's positive 3y. Negative 3 times 3z, that's negative 9z. And negative 3 times 13, that's negative 39. And this equation, I'm just going to copy it, leave it as it is. So then this is negative 3y plus 5z equals 27. And then as you can see, the y's are going to cancel or get eliminated. Now we have 9z, negative 9z plus 5z, that's negative 4z equals negative 39 plus 27, that's equal to a negative 12. And then we divide by negative 4. So then z is equal to positive 3. Okay, so then I'm going to come back to let's see, since we know what z is equal to, I'm going to come back to this equation here, okay, and substitute for z. So we have negative 3y plus, notice this has a 5 in front of z, so 5 times 3 equals 27. So negative 3y, 5 times 3 is 15, and then we subtract the 15 from both sides of the equation. So we have negative 3y equals, this is positive 12, then we divide by negative 3, so we find that y is equal to negative 4. Okay, so then the next step is I'm going to go to the first equation and find the x coordinate. So I'm going to come to this first equation here and copy x plus, instead of y is negative 4, so plus a negative 4, and then plus 2 times, instead of z, a 3, and that equals 3. Okay, So then we have x minus 4 plus 2 times 3, that's 6, equals 3. Well, negative 2 plus 6, that's 2. So x plus 2 equals 3. Then subtract the 2 from both sides of the equation. So then x equals 1. So then the solution to this system is x is 1, y is negative 4, and z is positive 3. So there we have the solution to this system of equations. Okay? All right, on the last example, we have, again, a system of equations with 3 variables. So make sure that the equations are in standard form. If they are not, then we have to rearrange all equations into standard form first before we start doing or eliminating. So notice this is 3x plus y equals 6x minus z. That z needs to be on this side. So that means I can jump the z to the other side. And since it's negative on this side, it becomes positive on the other side. So the first equation now is 3x plus y plus z equals 6. The second equation, the y should be second place after the x. So I'm going to jump this 2 y's to this side. Since they're positive on the right, I'm going to subtract them. So then the second equation becomes 3x minus 2y plus 2z equals 14. And the last equation, I'm just going to rearrange them because x should be first so that it's in standard form, and y should be second and z should be third. Just think of it as them being in alphabetical order. Okay, so 3x plus 3y minus 3z equals negative 6. So now they are rearranged in standard form. So I am going to take the first equation and the second equation. So I'm going to copy the first equation. This is 3x plus y plus z equals 6. And then multiply the second equation by a negative 1. Okay, so since it's positive 3x becomes negative 3x. And then the y's are negative. We multiply negative 2y times negative 1. That makes the y's positive 2y. And multiply the z's by negative 1. So then that changes to negative 2. Z equals 14, multiply that by negative 1 becomes negative 14. So then as you can see, the x's get eliminated. So we have y plus 2y, that's 3y. Z minus 2z, that's negative 1z. And 6 minus 14, that's negative 8. Okay, so then what I'm going to do next is I'm going to take, again, the first equation. So 3x plus y. Let's see, 3x plus y plus z equals 6, and then take the third equation. Notice I'm going to multiply this one by a negative 1. Okay, so then the x's become negative 3x, the y's become negative 3y, and the z's change to positive 3z, but then the 6 changes to positive 6. So again, the x's cancel, y minus 3y, that's negative 2y. Z plus 3z, that's plus 4z equals z plus 6 plus 6 is 12. So then I'm going to take these two equations. Okay, so then I have 3y minus z equals negative 8. And the second equation is negative 2y plus negative 2y plus 4z equals 12. Then what I'm going to do is I'm going to eliminate the z's. So meaning I'm going to multiply the first equation by 4. But you could also eliminate the y's. Okay. But if you want to eliminate the y's, you would have to multiply both of the equations. So then the first equation becomes 12y. 4 times negative z, that's negative 4z equals 4 times negative 8, that's negative 32. And then I'm just going to leave the second equation alone. I am not going to do anything to it. So plus 4z equals 12. So then I hope you can see that the z's get eliminated. So first, 12y minus 2y, that's 10y. Negative 4z plus 4z, they cancel or get eliminated. And then negative 32 plus 12, that's negative 20. Then divide by 10. So we have that y equals negative 2. Okay, so that's the y coordinate. So since we know the y coordinate, we can go back to either one of these two equations. I'm going to go back to the second one. Okay, but you can go to the first one too. You can go to either one of them. So negative 2y, y instead of y, we just found the y-coordinate. The y-coordinate is -2. So -2 plus 4z equals 12. -2 times -2, that's +4, plus 4z equals 12. Then subtract the 4 from both sides. So then we find that 4z is equal to 12 minus 4 is 8. Then divide by 4. So then the z coordinate is 2. Okay. So we have x, y, we have z and y. I am going to go back to, let's see, let's go to the second equation. Okay, let's go to this one here, the first equation. So going to the first equation that we rearrange, we have that 3x plus y is -2, and then plus z, which is +2, is equal to 6. So then the 2's cancel. So we just have the 3x equals 6. Then we divide by 3. So we find that the x-coordinate is +2. So then x is +2, right? That's the x-coordinate. Y is -2, and z is +2. So this is the solution to this system of equations. Well, thank you for watching. I'll see you in the classroom. Bye-bye.